Hi children, very good morning to one and all. Dear children, in the last class we learnt what is a vector, how to represent a vector and types of vectors. Dear children, in this class we shall learn the remaining concepts. First we have the position vector of a point. Position vector of a point. Here it is a three-dimensional coordinate system. So this is origin, x-axis, y-axis, and then we have z-axis, x-axis, y-axis, and z-axis. Let P of x1, y1, z1 be any point. So whose direction is from 0 to P, and this usually this is represented as r bar. Then the position vector of point P, with respect to origin. Here y is origin. Let O be the origin. Let P of x, y, z be the any point. Then usually this is represented as what? R bar. Then the position vector of a point P with respect to O is written as OP bar or vector R bar, vector R. Here then vector OP or vector R is the position vector of a point P with respect to origin O. So here again P is a point, O is the origin. Then we generally denote as what? O vector OP or vector R is the position vector of a point P of x, y, z with respect to origin O. Again, if AB is a vector, then this vector can be expressed in terms of its position vector. Generally we will write PV. So any vector can be expressed in terms of its position vectors. For example, if AB is a vector, then it can be expressed in terms of its position vectors. That is, vector AB is equals to OB bar minus OA bar. OB bar minus OA bar. Similarly, vector Mn is equal to On bar minus Om bar. Or similarly, the vector PQ is equals to OQ bar minus OP bar. So now OQ and OP are position vectors. Here this and this are position vectors. Any vector can be repressed or expressed in terms of its position vectors. Next we have direction ratios and direction cosines of a vector. Now let us consider the three-dimensional Cartesian coordinate system. This is x-axis, y-axis z axis. Consider the position vector of a point P of x comma y comma z with respect to origin O. Again, let alpha be the angle made by the r bar with x axis in the positive direction. Again, let beta be the angle made by the vector r with y axis in the positive direction of y axis, and let gamma be the angle made by the vector r with positive directions of z axis. Again, who be the origin? Let alpha be the angle made by the vector r in the positive direction of x axis. Beta be the angle made by the vector r in the positive direction of y axis, and gamma be the angle made by the vector r in the positive direction of z axis. Here alpha, beta and gamma, that is alpha, beta and gamma are called directional angles. Again, here alpha, beta and gamma are called directional angles, and that is cos alpha, cos beta and cos gamma are called as direction cosines. Alpha, beta, gamma are called as directional angles, and cos alpha, cos beta and cos gamma are direction cosines. Dear children, remember now our vector, position vector hengirutte andre, it will be like this, perpendicular to both this and this, okay, x axis, y axis, z axis, okay. So this will be like this, okay. So again remember, so here usually these numbers cos alpha, cos beta and cos gamma are denoted as L, M, N. The numbers cos alpha, cos beta and cos gamma are denoted by L, M, N, usually direction cosines. That is cos alpha is equals to L and it is given by, that is x divided by magnitude of r bar. It is a vector. Again, cos beta is equals to m, that is equals to y divided by magnitude of vector r. Again, that is cos gamma is equals to n is equals to y divided by magnitude of r bar, where magnitude of vector r is equal to square root of x square plus y square plus z square. Usually x, y, z are components of a vector. We will see that in the next topic. Okay, usually L, M, N, L, M, N are called as what? Direction cosines. Usually cos alpha is equal to L is equal to x by magnitude of vector, y by magnitude of vector, z by magnitude of a vector, z by magnitude of a vector. You should remember this again. If alpha is alpha, beta, gamma are the angles made by the r bar. Alpha, beta, gamma are the angles made by the vector r bar in the positive directions of x-axis, y-axis, z-axis respectively. Then alpha, beta, gamma are called as directional angles, and cos alpha, cos beta, cos gamma are called as direction cosines. So generally these numbers cos alpha, cos beta and cos gamma are denoted by L, M, N, which are given like this. Okay. So again note that is L square plus M square plus N square is equals to 1. Sum of squares of direction cosines is equals to 1. Okay. Again that is Li plus Mj plus N K is a unit vector, in the direction of a vector. So here L square plus M square plus N square is equal to 1. Number 2, Li plus Mj plus Nk is a unit vector, in the direction of a given vector. Next we have components of a vector. So we'll see what are the components of a given vector. Again consider the Cartesian coordinate system, that is 3-dimensional: x-axis, y-axis, z-axis. Consider point P of x, y, z, whose position vector is r bar. Whose position vector is r bar with respect to origin. Again let I be the unit vector, in the direction of x-axis, unit vector that is having one unit. For example 1 centimeter, 1 centimeter, 1 centimeter. Let j be the unit vector, in the direction of y-axis. Similarly let k be the unit vector in the direction of z-axis. Again I be the unit vector, in the direction of x-axis, j be the unit vector in the positive direction of y-axis, and k be the unit vector in the direction of z-axis. Okay. Then the position vector of a point P is given by, that is OP bar r, that is equals to vector r, that is equals to x into I, that is x into I plus y into j plus z into k, that is xi plus yj plus zk. So usually I, j, k are unit vectors. They are written as I cap, j cap, k cap. Generally we will write these unit vectors I, j can be written as I, j, k also. Okay. Next, so here x, y, z, that is x, y, z are called scalar component, are called as scalar components of a vector r bar, vector r. X, y, z are called as what? Scalar components of a given vector. And xi comma yj, comma zk are called as vector components. Vector components. Dear children, again here x comma y comma z are scalar components of a vector R, and xi comma yj and zk, where I comma j comma k are unit vectors in the directions of x axis, y axis, z axis respectively. So xi comma yj comma zk are called as vector components of a vector. Vector components of a given vector. Here again note that if a bar is equals to xi plus yj plus zk is a vector, then its magnitude, that is magnitude of vector A, is equal to square root of components, that is x square plus y square plus z square. For example, if a bar is equals to 2i plus j plus 4k plus 4k, then magnitude of a bar is equal to square root of that is scalar component we have 2 square plus scalar component we have 1 square plus scalar component we have 4 square. Again that is equal to square root of we have 2 square 4 plus 1 square 1 plus we have 4 square, that is 16. Again that is equal to 16 plus 4 20 plus 1 21, square root of 21. So this is the magnitude of the vector xi plus yj plus 2i plus I plus 4k. Okay. Next, the unit vectors in the direction of x-axis are given, x-axis, y-axis, z-axis are given by, that is 1 comma 0 comma 0, again 0 comma 1 comma 0, again 0 comma 0 comma 1. These are the unit vectors in the direction of x-axis, y-axis and z-axis respectively.